To solve for this integral, let's rewrite this as the integral of 1 times ln x. And now we could use integration by parts. So u is going to be equal to ln x, while v prime is going to be equal to 1. The derivative of ln x is equal to 1 over x, while the antiderivative of 1 is equal to x. Now we can use our integration by parts formula. So you have u times v. So we have ln x times x minus the integral of u prime times v. So 1 over x times x. And you can see the x's cancel out. So this gives us ln x times x minus the integral of 1, which is simply x, plus our c constant. And here is our final answer. In our next example, let's use integration by parts again. So u is going to be equal to ln x, while v prime is going to be equal to x. The derivative of ln x is 1 over x, while the antiderivative of x is equal to x squared over 2. Now let's use our integration by parts formula. So we have u times v, which is equal to ln x times x squared over 2 minus the integral of u prime times v. So that gives us 1 over x times x squared over 2. And you can see that the x and the x squared cancel. So now we're left with ln x times x squared over 2 minus the integral of x over 2. And let's evaluate this. So we have ln x times x squared over 2 minus, and the integral of x over 2 is simply x squared over 4. And don't forget our plus c constant. And here is our final answer. In our next example, to solve for the integral of ln x squared, it can be rewritten as the integral of 2 times ln x. And we could factor the 2 out of the integral. So we have the integral of ln x. And if you remember from our first example, the integral of ln x is equal to ln x times x minus x plus c. And we could just substitute the integral of ln x for this. So we have 2 times ln x times x minus x plus c. And now let's expand everything. So we have 2 times ln x times x minus 2x plus 2c. And since we have a 2c, it is a constant, it could just be rewritten as a c. And here is our simple final answer. To solve for this integral, we could rewrite this as the integral of 1 times ln x to the power of 2. And now we can use integration by parts. So u is going to be equal to ln x to the power of 2, and v prime is going to be equal to 1. The derivative of ln x to the power of 2 is simply 2 times ln x over x, while the antiderivative of 1 is equal to x. So now let's apply our integration by parts formula. So you have u times v. So we have ln x to the power of 2 times x minus the integral of u prime times v. So we have 2 ln x over x times x. And you can see the x's cancel out. And now we just have to evaluate the integral of 2 ln x. So we have ln x to the power of 2 times x minus 2 times the integral, 2 times the integral of ln x. So ln x to the power of 2 times x minus 2 times the integral of ln x is, remember, ln x times x minus x plus c. So now let's expand everything. So we have ln x to the power of 2 times x minus 2 ln x plus 2x minus 2c. And since c is a constant, it doesn't matter what coefficient we have at the front. So let's just write plus c. And here is our final answer. In our next example, we have the integral of 2x times ln x squared. So pause the video and try to do this yourself. So for this example, we can use u substitution, where u is going to be equal to x squared. So now let's substitute everything. So we have the integral of 2x times ln u. And now let's find the derivative of u. So the derivative of u, or the derivative of x squared, is equal to 2x. And let's rearrange everything else. So we have du over 2x equal to dx. And now you can see our dx can be replaced with du over 2x. So we have the integral of 2x times ln u du over 2x. And you can see the 2x's cancel out nicely. And that leaves us with the integral of ln u. And the integral of ln u is simply ln u times u minus u plus c. And our last step is to substitute u equal to x squared. So we have ln x squared times x squared minus x squared plus c. And here is our final answer. Thank you very much for watching, and if you found this video helpful, please leave a like and subscribe to the channel. And please comment down what other video topics you guys would like to see. Thank you.